Let's look at the graphs of sine, cos and tan and questions related to these. We need to know what the graphs look like. Let's start with sine x. It looks like this. So it starts at the origin and then curves up and curves down. The maximum is at 1 and the minimum is at -1. And then some interesting angles are 0, 90, 180, 270 and 360. Cos x is quite similar, but this time it starts at 1 and then curves down before coming up again. So the max is 1 and the min is -1, just like sine. And the interesting angles are also the same: 0, 90, 180, 270 and 360. The graph of tan x is quite different. It starts at 0 and shoots up. Then there's a dashed line here and the graph of tan x appears again at the bottom before curving up and shooting up again. Another dashed line and then another curve. There is no maximum and minimum for tan. It goes up to infinity and down to negative infinity. But the interesting angles are the same. So 0, 90, 180, 270 and 360 always. Those dashed lines are called asymptotes. And those are straight lines that the curve never touches or crosses. Now it's worth noting that the graphs actually do go on infinitely in both directions, but you only really need to be aware of the main pattern between 0 and 360, and then you can work out the rest from there. Let's have a look at some example questions. Example 1, here is a sketch of the curve y equals sine x for 0 to 360. So this is just like the one we saw earlier. And then it says, given that sine 30 is equal to a half, write down the value of other sine values. Now, if we find 30 on this graph, it'd be about there. And if I draw a line up from a 30 to the curve and then across, that looks to be about a half, as they said. Our job now is to look for 150 degrees, which would be around here, and figure out what the value of that would be. Now, if I draw another line up to the curve and then across, hopefully you can see that it also lines up with a half. So the answer there is a half, and that's all because of the symmetry of the sine curve. These curves are very symmetrical, so this gap would be the same as that gap. Next, we're interested in 330 degrees. So that would be around here. I'm going to draw my line down to where it meets the curve and then across. And again, because of the symmetry of the sine curve, this gap would be the same as the previous yellow gaps, which means that this value is in fact negative a half. Again, it's all to do with the symmetry of the curve. Example 2, here is a sketch of y equals cos x for values of x between 0 and 360. Then it says alpha is an acute angle and cos alpha equals k. Choose the value of cos 180 minus alpha. So first of all, let's find alpha on the sketch. It's here, and cos alpha equals k. Now we're looking for 180 minus alpha. So if that gap is alpha, 180 minus alpha would be around there. Draw a line down to the curve and across. And again, because of the symmetry of these curves, that value would be negative k. Last example, f of x is sine x minus 90. Choose the value of f of 0. So first thing I would do is sub 0 into this function. So that would be sine 0 minus 90, which is the same as sine of negative 90. Now, if we draw a sketch of sine, it looks like this between 0 and 360. But remember, it does extend infinitely in both directions. So if we draw the negative part of sine, it will look like this. And that would be negative 360. If I put the rest of the interesting angles on, so 90, 180, 270, and then their negative versions, we can now see that sine of negative 90 would in fact be at the minimum, which is -1. And that's the answer. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.